Back in 2000, very few people were doing pancreatic cancer research, and there was a big push in the community, in the scientific community, for cancer researchers to start studying pancreatic cancer. And it's been a resistance to it back then, and still even today, because it's such a difficult organ to study. I've been doing cancer research for about 25 years now, but I've been doing pancreatic cancer research specifically for about the past 10. Mostly because of the challenge of it. It's a very difficult disease to study, and it's one of the worst cancers there is to a patient. Now a lot of people took up the cause, including me. I wasn't doing pancreatic cancer research before, and then, like I say, the scientific community said, we need more people, and I said, sure, let's try that. I'll take all the information that I had from all the other cancers I was studying and put it into pancreatic cancer, and after that I got pretty obsessed with it.
I'm studying the role of proteases in pancreatic tumor formation, and using our model for pancreatic cancer. And by knocking out these proteases, we can study what effect that has on the pancreatic tumors forming. What I do is take these mice, and I take the pancreata from these mice and I analyze them using different histological stains, different markers for tumorigenesis, and try to figure out exactly what's going on in the presence of these proteases, and then what happens when we take them away. If the tumors still form, or if they get worse, whatever changes happen. That's how we figure it out. I just got really interested in understanding why and how these diseases exist and how they affect the body and result in death.
Now we're at the point where we understand a lot more about how pancreatic cancer forms, and we know a little bit more about why it progresses and why it becomes more difficult to treat as it becomes further along in the patient. Most of my work is trying to decide, or try to figure out, why the tumor forms in the first place and what are the signaling molecules that tell it to make a tumor. But there's been a lot of progress all the way to the end of life, at least in the animal models, that we are just now starting to apply to humans.
Fibrosis in the pancreas could be potentially bad when it comes to chemotherapeutics because of drug delivery. The fibrosis essentially creates a barrier around the tumor, so that it's possible that drugs can't be efficiently delivered to attack the tumor cells. What we found in our mouse model, when we knocked out our protease of interest and induced cancer, or tried to induce cancer in these models, we found that less tumors formed, and on top of that, even less fibrosis formed compared to mice that develop tumors normally. So that's a positive aspect to what we're studying.
Right now what we've found are a number of molecules that control the